Hello, welcome back to the workshop. Well, it's been quite a while since I've uploaded a video like this. I apologise for that. Things have got rather hectic at this end. Big jobs that needed to be got out and various things going on. There's a big project on the go in the background that you will find out more about as we get a little bit closer to the time. But for now, I thought I'd fill you in on one or two of the jobs I've been doing in the background. As this video progresses, you'll see me just doing some explanation about how the Verge Escapement works and some of the peculiarities of wear that can happen in a Verge Escapement. That was to do with a couple of movements that I just worked on that showed up a phenomenon. So I just thought that would be an interesting thing to capture. So there's that. I did some. I finished off the manufacture of a skeleton clock, a handmade skeleton clock, and I've just showed you in this video the process of machining the dial and finishing off the dial. So that I hope you'll find interesting, as well as a small job on a longcase clock as part of the restoration of a longcase clock movement, where I remachined the escape wheel to remove wear from the teeth of the escape wheel. So those are a few little bits of machining and things to look forward to in this video, as well as mentioning some shout outs to people who've been sending me stickers in for the sticker wall. If you'd like your sticker to be on the sticker wall, then please do drop me a line and we'll exchange details and stickers. So yeah, I'm always on the lookout to fill up the sticker wall, and you're very welcome to have one of my stickers. The big news in the background, while I've been a bit quiet on YouTube here, is that while I wasn't paying attention, the channel ticked over 10,000 subscribers. 10,000 subscribers. I can distinctly remember sitting here begging and pleading for that first 1,000 subscribers. So once you guys got going, you've really done me amazingly well. You've shown me a lot of support, and we've already made it to the 10,000 subscriber mark. So yeah, I'm really appreciative to each and every one of you who has liked and subscribed to to my videos, and yeah, hopefully I'll keep the content coming. On the topic of thank yous, I have to say a massive thank you to my patrons, because in the background they've been sticking with me and pledging their support, and that has enabled me directly due to the funding that they've provided. That has enabled me to get this project in, which is a rather nice longcase clock. It is coming up in an upcoming video series where I'll cover the restoration and conservation of this clock. The case is in the other room, dial is in the other room. I'll cover it all in detail in videos, but just thought I'd give you a little teaser here to show you what's coming up on the channel in the very near future. First episode of that video is filmed, and I'm actually in the process of editing it, so watch this space. Okay, so without further ado, here's the rest of the video. Thanks for watching. I've got two Verge bracket clock movements on test here, and I just thought I would demonstrate how to optimize the escapement. Now, both of these clocks are working fine, and there are no issues with either. But if I just show you this escapement has got has had previously some wear on the knife edge, and it's been filed up. This is how it came in, and a lot of Verge bracket clocks are like this because over the 200 or 300 years they've been running, the knife edge wears, it gets filed up, and what happens is the escapement arbor, the pallet arbor, no longer runs through its center line, so it doesn't pivot through its center line anymore. So I'm not sure if you can quite see there. It's actually describing a slight arc. It's not pivoting through its center line. Now this means that the rear pallet here sort of dances up and down slightly,
and it affects its drop off. It means that you can't have the escapement sort of set up as tight as you might like, so you're not getting the absolute optimum out of the escapement. I mean, as I say, it's not too much of an issue, and a lot of Verge bracket clocks have it, but it is not, strictly speaking, correct. It's not optimum. If we look at this one, where this was extreme, and I actually corrected it by rebuilding the back end of the Verge pallet arbor. So I cut the back off, and then I put a new section on with a new knife edge. So the knife edge is actually now through the center line, and if you look closely at that arbor, you can see clearly that that is pivoting through the center. So the escapement is more optimum. You can sort of set it up tighter with less drop, and it will escape. So I just thought I would demonstrate, as the two were parked next to each other, the phenomenon of the knife edge being through the center line, and how the importance of it if you're really looking to get the best performance out of a Verge escapement.
This is an escape wheel from a long case clock, 30 teeth, and it was really very badly worn. The tooth tips had all worn a large land on the top, which was sort of rounded over. But the wheel itself was original, and other than the wear on it, was in very good condition. The teeth weren't bent or chipped or damaged or anything, and it was running very concentrically. So I wanted to save it for the originality of the clock. So what I did was to make up this jig in order to hold it concentrically and clamp it down, and then I could recut the teeth rather than filing it. I mean, filing it up is the traditional way of doing it, but you're following what's there, and if there's any eccentricities in the cut, you're following them, and also you're highly unlikely to get it absolutely beautifully divided when you're touching it up with a file. So to recut it is in my eyes, the best way of doing it. So I made up this jig, and I had to do it in 2 passes because there was a slight difference between the commercial cutter and the shape of this tooth. I didn't really feel like making a fly cutter, which would have been the best way of doing it in terms of getting the exact shape of the tooth. But what I did, the curve was almost exactly the same as the commercial cutter, but it didn't. You weren't able to fill the gap. So I used the cutter to cut the curve, which stopped slightly short into the root, and then I moved the wheel on slightly and recentered the cutter and cut the backs of the teeth in a separate cut. And as you can see, there's 1 or 2 teeth where it's just missed the taking the full cut off the tooth, and that just shows that the original wheel was maybe cut very slightly off, but it's cleaned up the working faces on every tooth, and it's given a nice consistent land on the top of every tooth. As you can just about see the land on the top of the tooth there. So I'll take that out of the jig now, and you'll see that it's in my eyes quite a nice way of reviving the escape wheel. So you can see here the jig that I made up. It's just a piece of aluminium, and all I did was to through bore it to accept the pinion, and then to machine up a recess here to accept the collet. Now in this case, you can't always take this as read, but in this case that collet was absolutely bang on concentric to the wheel, and I did check this before going too far with this idea. If the collet is not concentric to the wheel, it would be possible to actually make a recess for the collet, and then to actually center the wheel by sliding it around until it was, if you oversized the bore and then slid it around until it was right. but that would be a much harder way of getting concentricity. But I was lucky that this collet was absolutely bang on. So with the jig on one side, you can see here the escape wheel recut, and that has saved the original wheel for this clock and given it hopefully another 100 or so years or more to fight another day. Hopefully in this little clip you'll be able to see the concentricity of the escape wheel between the plates. It's been maintained exactly as I was hoping. Absolutely bang on. So there's the escape wheel between the plates. It's running very true and very concentric. It's a job well done. Well, the poster's arrived and I've got a couple of stickers for the sticker wall. This one is from John, and he's just been doing working on a 3D printed watch case, stainless steel watch case that's 3D printed, and then he's been machining it. So his channel is really worth a look. And then Paul at the Knackler's Workshop, he is just about to start work on making a Congreve clock, so that will be an interesting one to watch. That's the rolling ball style of Congreve, that is the ball rolling down the table and then flipping back the other way. So it'll be an interesting one to watch him build. I'm going to be checking both of their channels out regularly, and they're going to go up on the sticker wall. Thanks very much, chaps. Remember, if you want to get your sticker up on the wall, I'm always up for doing sticker swaps. Send me one, I'll send you one of mine, and we'll get stickers up on the wall. Great to collect the stickers from some of the channels that I really enjoy watching on YouTube myself. Here's a sticker from David Lindo over in America. If you haven't already checked out him and the Plumier Foundation, then you really are missing a trick, because he is doing some absolutely superb work on some superb machines. So please go and check him out. So I've got this skeleton clock in at the moment for some work. Basically, this is a project that somebody had started and not finished, and so I've been commissioned to finish the job. So this clock has never been finished, never run. So I'll run through a couple of the things that I've had to do in order to get it somewhere near running. But a few of the finishing off bits and pieces that I need to do include the work on the dial. So that's what I'm going to cover now. I'm just going to show you the work that I'm going to do on the dial to finish it off. You can see here the dial, and I've put some blue Dicam on ready for the work that I'm going to do, but you can see it's already been pierced out, and very nicely as well, nice and sharp. And the center of the dial here, that's all sacrificial, that will be cut out, and that's one of the jobs that I'm going to do. But first, the minute track has not been marked. So there needs to be spots for the minute markers. So a heavy spot on the 5-minute markers, and then a lighter spot for the in-between minute markers. So I'm going to do that over on the BCA, and I've started with a plug here that is the center bore of my aluminium sacrificial plate on my rotary table on the BCA, and then this is the this sort of spigot section is the center of the dial here, so I can accurately center the dial to the BCA table, and that will enable me to divide accurately and spot the minute marker markings. First thing I'm going to do before going over to the BCA is, if you can see here, I've put a center pop on the spigot section of this.
I'm going to put that into here, and I'm going to mark the center line so that I know where I'm happy with where my my top to bottom center is going to be, and then the rest will be divided from there.
So I've just marked the centre line. Unfortunately, I forgot to press the record button while I was doing it, so apologies. The centre line runs straight through the 6, through the centre and through the 12, so I'm quite happy with that. So now I can go over to the BCA, mount it up, and we'll start on the 12 and we can divide our way around. So here's the setup for putting the spots on the dial. As you can see, I've just put one spot on already. Let's zoom in. You can see I've just done the 12 o'clock mark. That's not to full depth just yet, but I'm just making sure that everything is in the right place, what I'm expecting it to be. Right then, I've just been round again with a larger drill, in this case a 1.8, so that I can hide the tail of the 10BA thread that's going to mount the dial feet. And that is just, as you can see, on the 5-minute markers. So that is now the spotting of the dial complete. They will be filled with black wax to complete the job, and the next stage will be to mount the dial while I've still got the center available, and then bring it back onto this faceplate to machine the dial center away. Right, so here's the dial, and you can see the marks, the minute marks that were just machined in the BCA jig borer, and then the 5-minute markers. Now the 5-minute markers are designed to hide the end of the thread of a small thread. In this case I'm using a 10BA to mount the dial feet. Dial feet will be screwed from behind, So the next job, while I've still got the centre available, before this is trepanned out, milled out, and then the dial finalised, while I've still got this centre available to me, I'm going to use it to centre up on the centre arbor here. So I've made just a little spigot out of a piece of scrap, and that fits nice fit into the centre, and then a nice fit into the centre of the dial here. I've also, you can see these marks, scribed a very light centre line from either point of the plate here, and to try and give me the centre of the dial. So I can then line up the dial using the centre line that I made on the dial itself, and there. So the dial is now lined up, centred to the plates. I'm just verifying idiot check that I've got 12 and 6, and that the dial is the right way up. So both of those things are okay. So no silly mistakes today, please, Mr. Jobson. And I'm just going to use these toolmaker's clamps to pinch the dial just against the plate lightly, just to hold it in place. And then the next job will be to drill straight through both the dial and the plate with tapping size for a 10BA. So toolmaker's clamp on. I'll put another one down here. Just checking that I'm still centered, which I am. So I'll be drilling straight through with a 1.4mm drill, which is tapping size for 10BA, as I say. There we go. So you can see here that if you can just catch the line in the light, you can see here there's the scribe line here, which you can just catch in the light, and then that's carrying on through, and you can also see the scribe line through the dial itself. So that means that the dial is nice and centered. And it's always a good idea just to hold it up at a distance and just visually check, but it does look good. So the two holes for the dial feet are here and here into these wings. So I'll go and drill those 1.4mm straight through everything now. Okay, so I've drilled the two holes, and I'll just take my toolmaker's clamps back off, and then the dial is now loose, so I can take the spigot away, and you can see here we've now got the locations of the dial pillars relative to the holes here in the dial. Now these holes are to be tapped 10BA, ready to accept the dial feet. So the dial is now all dotted out, and the holes here for mounting the dial feet are drilled and tapped. Now the drawing does actually show the dial pillars as having a sort of a boss on both ends, but I can't actually get this size of boss out of the size of the rim of the dial, and the dial had already been made, so that small diameter there is dictated. So what I've done, I've made the dial pillars to be the same, the rest of the dimensions and everything to be the same, but just deleted that boss on the end. So I've made these two dial pillars, and they have a thread in the end, Loctited in, which is domed, and that steel thread will hide in the bottom of one of the 5-minute markers, hopefully. So these are 10BA. It's all a little bit small, for the scale of the dial. Smaller than I would have liked to have designed it myself, but it's what we've got to work with. So okay, so those are in. So you can see that I've got it so that the taper comes down to the edge of the dial. Now, if I had the boss as the drawing shows, then you'd have this boss visible there. So I think it looks fine like that. So then the dial, we've got the 2 holes that drilled earlier, and the dial will stand like that, screwed from the back. So the last thing to do machining wise on the dial is to machine out the inner disc, and then I can do the sort of finishing work and putting the black wax into the holes, graining it and silvering it, and that will be the dial complete. Right then, so returning from the milling machine, and the dial centre has been trepanned out, milled out on the rotary table on the BCA. So that's come out quite nicely. I did go around again just to bring this down to dimension, this rim down to dimension, and to also put a nice surface finish on the inside there, which will make papering up to standard a lot easier when we come to doing that in a minute. So the finished result will be something along those lines. So the next stage will be to fill in these dots with black wax, and then to grain and to silver. So after obviously a little bit of finishing work first. So that's approaching completion of the dial. So I've just waxed the dots by using this hard black shellac wax and melting it using the hot plate like you've just seen into the dots. And the next stage is to abrade off the surface of the wax to leave the dots visible and black infilled.